Here's how we want our final output to look, and you can see under serial decoding, here are my configurations. So my data is on B, clock's on A, rising edge, most significant bit, 8 bits. Cancel that and go to the trigger, which is right here, auto trigger, pulse width, channel A. You can see that set up here. Make sure you move that threshold at least one time or it won't read properly. And you want the direction to be a negative edge, and it triggers on the first rising edge, and the pulse width has to be greater than 2 milliseconds. It's this amount of low time. Okay, and it is low for a long time. So let's do a reset configuration and see if we can get back to this. So here we go, reset configuration. Okay, and here what you're getting is kind of odd looking because it's just a very short pulse every once in a while. Because if we look at our program, here's our program, and I'll just scroll through the whole thing, but we have a fairly long delay because we're actually printing the code. So when I run the program, and let's do that and turn on serial decode, you can see that it's 173, representing a resistance of 6,747 ohms. And 173 is equal to AD in hexadecimal. So let's go back to our Picoscope. And actually, let's just try changing the vertical settings. So click on this, probes. We're always going to be times 10. We're going to do the same thing for A. But while we're here, let's just turn on the trigger. And I find this part a little bit annoying that I've set my trigger to 1 volt, but it always sits at the top initially. So I can drag it down if I want, and at least it does trigger on that information. But be careful of that. It doesn't start off with the value shown in the screen. So now that at least I have some trigger, I'm going to change the time base so I can read that a little bit better. Okay, and this looks like our clock signal because it's 2 bytes of information with a whole bunch of clocks here, another big bunch of clocks here. And let's turn on the other channel, so channel B, probes, standard times 10, and we're already, well, we're not at plus and minus 10, so we'll switch that, turn it on, manual, plus and minus 10. Now they're overlapping, which is not great. So to get rid of that, you just drag this up here and get it so that this part shows 0. Same thing for this red line, drag it down. It's probably easier to drag on the 0 and just bring it down, but don't have it say 0.4. It's not easy to read that way. Have it say 0. So this one says 0. So the red line scale is on the right. The left scale is on the left-hand side. And all of that seems to be okay, but I want to get it to trigger at this 20% point. So go back to trigger, and we're going to move it to the 20% point, and we're going to change the type from a basic to a pulse width. It's going to be positive, greater, and then we're going to get this to be, let's say 6 milliseconds. Okay, and then click on that. Oops, sorry, let's go back to that trigger. One of the things that's very important here, because the others were positive, this is going to be negative because it's going to be a low edge and then trigger on the first rising edge. So the direction should be negative here. And I've selected greater than 6 or 7 milliseconds, seems to be doing that. So that's fine. So we've got A, B, the trigger. Now we have to go to serial decode. So select serial decode, and we want to choose SPI SDIO. And then next to that, and some of the settings here is our clock signal is on channel A, our data signal is on channel B. We want to have a rising edge. The bit order is most significant bit first. It's 8 data bits. I think everything is set up correctly there, so select next. We want both the graph and the table to read in hex. So I've finished that. I'm going to bring the table up so that you can see it. And move the serial decoding to the middle here, and then I'm going to run it, and it seems to be reading our information correctly because it's 00 AD, and you can see that in our table down here. If I wanted to measure the period of the clock signal just to verify it is what we expect, I can zoom in a little bit, so change the time base. And then you can also bring cursors so that you can measure. So you go to rulers. Okay, and if you want to turn on the graph rulers, and you can see there are rulers down at the bottom here. So there's one for this amount of time. So I'll measure that time, and then this time. And we're operating, I believe, at a 1 megahertz clock. So it should be a microsecond. Okay, 1 over 1 megahertz is 1 microsecond. So it seems to be agreeing with what we expected. Very good. Okay, that'll be it. And that's for the SPI.